Alrighty, so this is videos for 9.5, factoring x squared plus bx plus c. So just a reminder that factors are things that can be multiplied together to get a product. So 4, 6, 3, and 8 are all factors of 24 because 4 times 6 gives us 24 and 3 times 8 gives us 24. We can also find variable factors. X squared and x are factors of x to the third because x squared times x multiplied together gives us x to the third. So what we're going to be doing is instead of factoring out a number or a variable, we're going to factor out polynomials from a larger polynomial. So for example, if we're given the polynomial x squared plus 7x plus 12, we can factor it into smaller polynomials of x plus 3 times x plus 4. So because x plus 3 and x plus 4, when multiplied together, give us x squared plus 7x plus 12, those are factors of x squared plus 7x plus 12. We can test this by multiplying it out. We have x plus 3 times x plus 4. We distribute and get x squared plus 4x plus 3x plus 12, which when we combine like terms, we do get x squared plus 7x plus 12. So they are in fact factors. And we call the form x plus 3 times x plus 4 the factorization of the larger polynomial x squared plus 7x plus 12. So notice here we have x plus 3 and x plus 4. 3 plus 4 gives us 12, which is, 3 plus 4 gives us 7, not 12. 7, which 7 is the number in front of the term that just has x, or the coefficient in front of x. And 3 times 4 gives us 12, which is the last term, or just the number. So this pattern is always going to be true, and we can use it to help us factor. So if we have x plus some number, we'll call it p, and x plus some number, we'll call it q, and that is equal to the factorization of x squared plus bx plus c, where this b and c are also numbers. We know that b, the term in front of x, is going to be equal to the number p plus the number q, whatever numbers are in there added together. And c, that final constant term, is going to be equal to those numbers p and q multiplied together. So if we know what b and c are, they can help us define what numbers we can plug in for p and q in order to factor the polynomial. So looking at example number 1, it asks us to factor x squared plus 9x plus 20. So our b here, our term in front of the x, is 9, so 9 has to be equal to whatever we plug in for p and q added together. And our final constant term is 20, which is equal to c here. So 20 is going to be equal to whatever we use for p and q multiplied together. So our solution is going to look something like x plus some number p times x plus some number q, where p plus q equals 9 and p times q equals 20. So we're going to start off by looking for which two numbers multiplied together give us 20, or what two factors of 20 we can use for p and q that also, when added together, sum to 9. So we're looking at factors of 20 that, when added together, sum to 9. So 9 is what we're looking for here. So let's start just by thinking of factors of 20. Well, I know that 1 times 20 equals 20, so 1 and 20 are factors I could use. But the sum of those factors, or 1 plus 20, equals 21. That doesn't give us 9, so we're not going to use those factors. Next, I'll try 2 times 10, which gives me 20, but 2 plus 10 gives me 12, which is not 11, not 9, not what I'm looking for. Next, I'll try 4 times 5, which gives me 20, and 4 plus 5 is equal to 9, which is, in fact, what I'm looking for. So the factors I'm going to use here or the values for p and q, are 4 and 5. So we can just write x squared plus 9x plus 20 is equal to x plus 4 and x plus 5. So after finding these values, we just plug them in for p and q. We can check this, though, to make sure that we did it correct by multiplying the polynomials out. So if I multiply x plus 4 and x plus 5 by distributing, I get x times x is x squared, x times 5 is plus 5x, 4 times x is plus 4x, and 4 times 5 is plus 20. So when we simplify by combining our like terms here with x, we get x squared plus 9x plus 20, which is in fact our original polynomial. So we did factor correctly. So our solution is, in factored form, x plus 4 times x plus 5. So we took a bigger polynomial and simplified it by factoring it into smaller polynomials. Let's look at another example. Number 2 on the next page. It asks us to factor x squared plus 11x plus 24. So again, we want to find some p and q, so our answer will be x plus some number p times x plus some number q, where p plus q gives us our middle coefficient of 11, and p times q gives us our last term, 24. So first, let's look at factors of 24 and see if those sum together to 11. So, starting again with 1 times 24 gives me 24, and 1 plus 24 gives me 25, not what I'm looking for. Next, I'll try 2 times 12, which gives me 24. 2 plus 12, summed together, gives me 14, also not what I'm looking for my middle term here. Next, I will try 3 times 8, which gives me 24. 3 plus 8 gives me 11, which is in fact the coefficient of our middle term. So the numbers I'm going to use for p and q are 3 and 8. So my answer will be x plus 3 and x plus 8. Again, I can check by multiplying. So I'll distribute x times x is x squared. X times 8 is plus 8x. 3 times x is plus 3x, and 3 times 8 is plus 24. We can combine our x's together here, so we get x squared plus 11x plus 24, which is our original polynomial. So our factorization is correct. So our answer in factored form is x plus 3 times x plus 8. Alright, so do the exact same thing on checkpoints number 3 and 4. On number 3, again, you're finding the factors of 6, or what values you can multiply together to add up to 6, your last term here. And you want the sum of those factors to give you the coefficient of your middle term, which is 5. 5 is what you're looking for over here. And check your work. And on number 4, you are trying to find the factors of your last term, 10, and you want the sum of those factors to give you your middle coefficient here of 7. And again, check to make sure that the value or the polynomials that you find do in fact multiply together to give you the original polynomial. Alright, we'll check numbers 3 and 4 in class tomorrow.